Look up tonight. There's a star down there in the southern sky, so close in cosmic terms that it feels like it should be reachable. Proxima Centauri. It's the nearest star to the Sun, about 4.24 light-years away. And around it, there's a planet that shook the entire idea of home for our species. Proxima Centauri b. Not confirmed to be Earth 2, not proven to have an atmosphere, but real, discovered, and sitting near its star's habitable zone. So here's the question that hurts. If it's our nearest neighbor, why does it still feel like it's on the other side of the universe? Because the universe doesn't block you with walls. It blocks you with distance. And the moment you translate 4.24 light-years into real numbers, your brain starts to understand the trap. Light-years aren't a dramatic sci-fi unit. They're a warning. A light-year is how far light travels in a single year. So when a star is 4.24 light-years away, you're saying this: even the fastest thing in the universe needs more than 4 years just to get there. And we are not the fastest thing in the universe. Right now, our best escape velocity from home record holders are probes. Voyager-1 is moving about 17 kilometers per second relative to the Sun. That sounds fast until you do the time math. At that speed, a trip to Proxima Centauri would take tens of thousands of years. Not decades, not centuries. Civilization length. And that's not even the most brutal part. The brutal part is that Voyager-1 is not a ship, it's a message in a bottle. It has no shielding for an interstellar storm at high speed. It has no plan to slow down. It has no ability to aim for a planet like Proxima b. It's just coasting. So if we want to reach Proxima b in a time span that means anything to a human life, we need a different kind of travel. We need a different kind of speed. Let's be generous and say you want to arrive within a lifetime. You'd need something like a significant fraction of the speed of light. Even 1% of light speed changes the story. But 1% of light speed is about 3,000 kilometers per second. That's not a better rocket. That's an entirely different era of physics and engineering. And even if you somehow build an engine that can reach those speeds, you run into the problem most people forget. Acceleration is only half the mission. You also have to slow down. If you don't slow down, you don't reach Proxima b. You perform a flyby. At 0.2 c, 20% the speed of light, you would cross an entire planetary system in hours. Imagine trying to study a world, detect its atmosphere, map its surface, and search for signs of habitability while screaming past at a speed where a grain of dust can hit like a bullet. This is where interstellar travel stops being romantic and becomes terrifying. Because space is not empty. Between stars, there is dust, there is gas, there is radiation, and at relativistic speeds, small becomes deadly. Now stack on the next reality. Proxima Centauri is not a calm sun-like star. It's a red dwarf. Red dwarfs are small and long-lived, which sounds good, but they can be very active, throwing flares and bursts of radiation. Proxima b orbits extremely close to its star, around 0.05 AU. That's roughly 20 times closer to its star than Earth is to the Sun. So even if Proxima b is in the habitable zone by temperature, it might be living in harsh space weather. It might be tidally locked. It might have lost its atmosphere. Or it might have a thick atmosphere and survive in ways we haven't seen before. And that uncertainty makes it even more urgent to visit. Because the closest potentially habitable exoplanet is also the most realistic place to test our biggest question. Can a world around a red dwarf actually stay alive? But here's the catch. To answer that question properly, we need close-up data. And to get close-up data, we need to get there. So if it's impossible, what do scientists mean? They don't mean never. They mean something more frustrating. With today's energy, today's propulsion, and today's materials, we cannot send humans there in any reasonable time. Not safely, not sustainably. But probes? Probes might be a different story. And that's where the future gets interesting. Because there is one idea that doesn't try to drag a whole ship to the stars. It tries to send a whisper, a fleet of tiny, fast machines. And they don't ride explosions. They ride light. If you want a realistic path to Proxima b in this century, you have to stop thinking like a crude mission. You have to think like a signal. That's the philosophy behind one of the boldest proposals ever made, a laser-pushed light sail. The concept is simple to say and brutal to build. You build a powerful laser array, you aim it at a wafer-thin sail, and you push a tiny probe so hard with photons, pure light pressure, that it reaches a significant fraction of the speed of light. Not with fuel, with an external power source. The most famous version of this idea is often discussed under Breakthrough Starshot. The target speed people talk about is around 0.2 c. At that speed, the travel time to Proxima Centauri is roughly 20 years. Then you add about 4.24 years for the first signal to come back, because radio waves still travel at light speed. So you're looking at something like launch today, arrive in 2 decades, here back in the same generation. That's not fantasy. That's a real timeline if the engineering can be solved. But the devil is in the details. First, the probes have to be extremely small, grams to maybe tens of grams, not 100 kilograms, not a spaceship, a microcraft. Second, the laser array is beyond anything humanity has ever built. You'd need an insanely coherent and insanely well-aimed beam operating at enormous power, keeping the sail stable, correcting for atmospheric distortion if it's ground-based, or being built in space with its own challenges. Third, the sail and the probe have to survive acceleration forces that would destroy normal spacecraft. Fourth, there's the interstellar dust problem. At 0.2 c, even tiny particles become impacts with huge energy, so you either need clever shielding, a way to angle and minimize cross-section, or you accept that many probes will die, and you launch a swarm so that some survive. And then there's another brutal truth. A Starshot-style mission is almost certainly a flyby. Slowing down from 0.2 c into orbit is a completely different level of difficulty. So these probes might not arrive like a spaceship arrives. They might screen through the system, grab whatever data they can, and beam it home. Which sounds disappointing until you realize what it could still mean. Even a fast flyby could potentially tell us things we cannot know from here. Is there an atmosphere at all? Are there clouds? What's the composition? Is the planet a barren rock, an ice world, or something stranger? Are there signs of magnetism? Are there hints of chemistry that shouldn't be there? It wouldn't answer everything, but it would change everything. Because once humanity receives the first close-up data from another star system, the way we think about other worlds stops being speculation. It becomes geography. Now, what about sending humans? This is where the story splits into 2 futures. Future 1 is biological, a generation ship, a multi-century mission, people born, living, and dying in transit. It's not impossible by physics, it's just extreme by civilization. You're not launching a mission, you're launching a moving society. Future 2 is post-biological. AI probes, robotic infrastructure, self-repairing machines, possibly even autonomous factories that arrive first, build what's needed, and prepare the system for whatever comes next. In that future, reaching Proxima b doesn't mean sending a human body across the void. It means sending intelligence. And that might be the real twist. The first thing to reach another star may not be a person. It may be a lens, a camera, a chip, and a laser transmitter. A tiny mind, a tiny eye, a message that says, "We made it." So, is it impossible to reach Proxima b? For humans with today's technology, yes, in any meaningful time frame. But for probes, the gap is no longer infinite, it's engineering. And engineering has a history of turning impossible into routine, one breakthrough at a time. Now here's the question that matters. If we finally get close-up data from Proxima b, what do you think we'll find first? A dead world stripped by flares? A thick atmosphere that somehow survived? A twilight planet with permanent day and night, or something we haven't even imagined yet? Tell me your best prediction in the comments. And if you want to explore what humanity might become beyond Earth, beyond tomorrow, beyond 2200, subscribe.